So now we're going to go step by step through the image intensifier, which what makes the whole fluoro thing possible. So step one, we have the input phosphor. We're going to go layer by layer. X-rays from the patient strike the input phosphor, which is made of cesium iodide. This layer converts X-rays into light, and that is called scintillation. It's also kind of the same thing as a scintillator if you remember my old video on DR versus CR. If you need to brush up on that topic, just make sure you go back to it. But yeah, then next we have the photocathode. That's step two. Right next to the phosphor is the photocathode, and it's made of cesium and antimony. It absorbs light and it emits electrons. Think of this like turning visible light into electron signals. Important note, this is not a photoconductor. Photoconductors convert X-rays directly into electrical charge, like in digital detectors. That's not what's happening here. Step 3, we have the accelerating anode. The electrons are pulled toward the output by the positively charged anode. It accelerates them, but it doesn't get struck on the anode like how a regular X-ray tube would. There's a hole in the center where the electrons are going to pass through. So step 4, we have electrostatic lenses. These lenses have a negative charge and they act like a funnel. They focus the electrons toward the center of the tube in a process called electron optics. Step 5, we have the output phosphor. Finally, the electrons hit the output phosphor, and that's made of zinc cadmium sulfide. This layer converts the electrons back into light. Because this phosphor is smaller than the input phosphor, the image gets compressed and appears 50 to 70 times brighter than where it started. Alright, so let's run it back one more time.